Hello everyone, let's talk about polynomials. So first thing, when we say what is a polynomial, what we are looking for are anything that, what you're looking to break a polynomial, I should say, is if you have negative or decimal exponents. So a polynomial is an expression with whole number exponents. That's a pretty basic definition, but basically what we're looking for is whole numbers are 0, 1, 2, 3, 4, 5. They're positive, they are not negative, and they should not ever be decimals. So we should not have decimal exponents. If we have a decimal in our exponent or a fractional exponent, that is not a polynomial. The leading coefficient is the term in the front of the polynomial. So this is the coefficient of the term with the highest degree. We'll talk about degree here in a second, but that is the leading coefficient. It's got to come in standard form. It's got to be the highest degree first, okay? The degree is the highest degree of any term in the polynomial, and we should put that in standard form in the beginning. And the constant term is the term with no x, and it is the y-intercept if you're in standard form. And we'll talk about all these things more. These are all words that you've heard, but we're going to put them all together and define polynomials. First thing, when we have the name of a degree and we have the name of the number of terms, there's some words that you need to know. So let's do the degrees first. If a number has a degree 0, like the number 7 has degree 0. Okay, so I'm going to give an example. Degree 0 is like the number 7. That is called a constant term. It doesn't vary, so that's called a constant. I'm going to type so it's easier to read. Constant, okay. A degree 0 polynomial is called a constant. It'll just be a number. A degree 1, so if you have something like 7x plus 1, 7x plus 1, that's x to the first is the highest degree. So that would be called, if you graph it, you'd make a line, so we call that a linear polynomial. If you have a degree 2, that's what we've been doing most of this semester, something like x squared plus 3, degree 2, that's called a quadratic. And we've done the quadratic formula, and we factored a bunch of quadratics. After that, we've got x to the third, so something like x to the third plus 2x plus 5. The highest degree in there is 3, so that is called, we read that x cubed, that's called a cubic polynomial. And then the last one that we will memorize is to the fourth. If it's something like x to the fourth plus 6, that would be, instead of a cubic, that's called a quartic. Like a string quartet, it's a quartic. After that, we'll just say it's an nth degree polynomial. We're not going to memorize every vocab word that's ever been, but those 5 are fair game. Constant, linear, quadratic, cubic, and quartic. So there's 2 parts to naming a polynomial. The first thing is based on its degree. The other one is how many terms there are. Now, if there are no terms, you can't name a polynomial that has no terms. You just be like, there's nothing to name. So we're not going to do that. But if it's a single term, like 7 is a single term, the prefix that we use for 1 is mono, so it's called a monomial. Monomial has a single term. If it's got 2 terms, like this guy, 7x is one term and 1 is another term, that's called a binomial. So if I said name 7x plus 1, this is linear because it's degree 1, and there are 2 terms, so it's a binomial. This is a cubic because it's degree 3, but there are 3 terms, so we call that a trinomial. Monomial, binomial, and trinomial. And after that, we're just going to say it's a polynomial with however many terms. So this is going to be a polynomial with 4 terms. And then we would just say, if it's got 10 terms, we would just say it's got 10 terms. So a polynomial with n terms, however many there are. If there's 15 of them, it's a polynomial with 15 terms. Okay, we only have 3 to memorize here. Monomial, binomial, and trinomial. And those vocab, those prefixes are pretty familiar, so you should be able to remember those pretty easily. So first, is this a polynomial function? The answer goes back to our definition here. We should have whole number exponents. And here you can see that 2.5, that's not a whole number, so this is not a polynomial. And you should always be able to say why it's not a polynomial, because 2.5 is not a whole number. You see why I typed before. Okay, 2.5 is not a whole number, so this is not a polynomial. But this one is a polynomial because you have 2 1, and 4. I don't care that 3.7 is a decimal, it's the exponents. Now, to put it in standard form, I would say 9x to the 4th plus x squared plus 3.7x. Descending order. 4, 2, and that's an implied 1. So that's standard form. Now, if I said state its degree is 4, so this is a degree 4 polynomial. Its type, it's a cubic, because there's, oh, it's not a cubic, there's 3 terms. It's a trinomial because there's 3 terms. It's degree 4, so that would be a quartic, okay, based on the name. Degree 4 quartic, and since there are 1, 2, 3 terms, that is called a trinomial. So this is called a quartic trinomial because it's degree 4, and there are 1, 2, 3 terms. This is a quartic trinomial. The leading coefficient would be 9. Okay, it's right there, the coefficient of the leading term. You put it in standard form, and then you can name it, and I can have you say, like, what's the leading coefficient? Is it positive or negative? That's where we're headed. Okay, the other thing we're going to talk about is substitution, and this is called direct substitution. This is what we normally do. If it says when x equals -2, they just want you to plug in -2. So I'm going to plug in -2, and I'll use my calculator. -3 times -2 to the 3rd plus -2 squared minus, oops, I did this wrong. That's to the 3rd, okay, plus -2 squared plus, no, minus 12 times -2, and then minus 5. So everywhere you see an x, you're going to plug in a -2. So instead of x cubed, it's -2 cubed, -2 squared, 12 times -2. Good, we get 47. So if I say what is f of -2, you get 47. When you plug in -2, you get 47. We're used to doing that. That's called direct substitution. That's when you just plug it in. But what I'm going to show you now is a fancy thing called synthetic substitution. So synthetic substitution, we're going to do another substitution here, but we're going to do it what's called synthetically. This looks like a magic trick when you see it. You're like, what? How did that work? First thing, when you write your coefficients in standard form, descending order, make sure you include any missing terms as 0. If you don't, you will get these wrong. Okay, and what I'm going to do is I'm going to just set this up and I'll kind of explain to you what's going to happen. But we're going to put the coefficients in descending order. This is degree 4, so I put a 2. Then degree 3, I put a 3. Degree 2, I put -6. There is no x to the 1st, so we have to put a placeholder 0 there. If you don't do that, you will get it wrong. And then the last term is a 3. Okay, I'm plugging in 2, so I put a 2 on the outside. This is just how you format it. Okay, it looks weird, but you'll see in a minute. Now, before I do it synthetically, I'm going to plug this in directly. I'm going to use direct substitution, and I'm going to show you how it works. Plus 3 times 2 to the 3rd. Oops, gotta keep doing that. Minus 6 times 2 squared plus 3. Okay, I'm going to get 35 for my answer. When you plug 2 in, you get 35. But I'm going to do this synthetic substitution, which looks completely ridiculous right now. It's sort of a magic trick. Here's how it works. You list your coefficients, 2, 3, -6, including any zeros. If there's a placeholder, you need to have a 0. And then 3. Bring down the leading coefficient. Okay, so I bring down the 2, and now I'm going to multiply. 2 times 2 is 4, and you put the 4 right there. Okay, you put it underneath the next row. Now we just repeat this process by adding. 3 plus 4 is 7, and now I multiply 2 times 7, and I get 14. 14 minus 6 is 8, and now I multiply. 2 times 8 is 16. 16 plus 0 is 16. 2 times 16 is 32, and when you add them together, you get 35. Okay, this is the answer. When you do direct substitution, by plugging in 2, what I learned is I will get 35. This is called direct substitution, okay? So, or this is synthetic substitution. We just did it directly and synthetically now. Let's do another one using synthetic substitution. So first, you make this like L, and then you put all of your coefficients here. I have 3, 2, 1. I'm not missing any, so that's good. I put my coefficients in 5, -6, 11, and -15. and then I put a 7 right there. So to do synthetic substitution, you bring down the 5, and now you multiply. 7 times 5 is 35. 35 minus 6 is 29. You multiply. 203. Okay, that's wrong. That might be right. 7 times 29. Yeah, good. Okay. Add 203 plus 11, 214. 1,470 and 28. I think it's 1,498, but let's check. 214 times 7. 1,498. Subtract 15, and you get 1,483. Okay? So that's using synthetic. To check it, I'm going to plug in 7 directly. To the third minus 6 times 7 squared plus 11 times 7 minus 15. I should get the same answer, 1,483. Good. Okay? So you're doing something here that we don't necessarily need to know about just yet. These numbers do matter. We just don't care yet. Right now, we're just teaching you the skill. So this is called direct substitution. This is synthetic and direct substitution. This is synthetic. One more. I'll do another synthetic one, and then we will do some practice. So -3 is what you're plugging in. That goes on the outside. I have degree 4, degree 3. I don't have a degree 2. I have a degree 1. I'm going to need a placeholder. So degree 4, the coefficient is 1. Degree 3, the coefficient is 2. There is no x squared term, so I need to put a 0 in there. 3x and then -7. And now I play this game where I bring down the 1, and now I multiply, and then I add. Multiply, and then I add. Multiply, add, multiply. 18 minus 7 is 11. So the answer should be 11. And at this point, I'm going to check it. -3 to the 4th plus 2 times -3 squared, no, cubed, plus 3 times -3 minus 7. If we did it correctly, using direct substitution, we should get the same thing as when we did synthetic substitution. We got 11. Good, so I know I did it right. Okay, so practice your synthetic substitution problems and make sure you hit that like and subscribe.